what's this? We have a maybe I not edit. Edit? My boss lah, my ex-boss before.
So you married?
Huh?
You married?
I'm married. Not yet.
Oh yeah. Single, double,
Triple.
triple, 会玩。
最少奋斗10年了。
Yeah, so today time comes very fast. Here comes to our last practical here. We have already covered what? Machine learning, NLP, image processing, recommender system, and neural network. So neural network is a part of the machine learning. And what else do we cover? The fundamental of Python. Yeah, almost everything now.
Then what comes after this?
What comes after this? So next week, I will use this for assignment discussion, or maybe you would like to continue assignment. You can. You come out. If you don't want to come, then you. I can do it.
这工作直接给麻烦。
Oh.
你也不用改，旁边了。
If you feel satisfied only if you complete the task. If I do, I give marks, then you won't feel the satisfaction, you know. You don't have satisfaction.
Need a 4.0.
Satisfaction is when next time you open our there are 4.0
But if you look at the 4.0, then it's done by you, then you okay.
You still feel like it's not by us one.
Gen Z generation.
Sakit hati lah. If everyone I give 100 marks, then everyone will be equal.
No need 100.
No special. No special, then everyone also equal, then like
No one special.
you go to Wanton-Mee, you every store also the same taste. What you feel?
Not bad lah, because the country is not equal already.
Very good. Not good. You feel same taste. You cannot compare. So you must have some.
Problem like every time the same thing also so profitable.
Some McDonald's food taste, some McDonald's chicken very small, some chicken very big. There's some differences. The taste the taste KFC different. Different branches, different taste one. KFC.
Yeah, KFC different but
Very different now. McDonald's quite consistent. KFC, the division is very big. Some very oily, some very dry, some very sweet taste, some very.
you can all be like McDonald's.
You all want to pick up one like McDonald's.
No, they graduate all work at McDonald's.
Okay.
是我们介绍你女朋友啊。
谢谢 Thank you very much.
有2个，什么班的有？
哎，只是看感情的吗？有看嘞。
Okay, so come to the practical 6, the last practical. The last one, then I put a set thing. So inside this folder, there's only one Python file and there's one only data set, which is called the flowers iris dataset .csv file. No module name, because before you start to run this code, make sure that you run this first new law lab. Okay, so you have to add this code before you run when you start the first cell here. So neural net is basically a library for neural networks. If you want to build neural networks, then you need this library. If you don't want to use neural net, then you can use TensorFlow, yeah, you can build the neural network using TensorFlow also. But neural net is another library. So I use neural net because it's very simple, easy to understand compared to the TensorFlow where you need to define your own layers, very complicated. Okay, so you still remember last week the neural networks? How neural network works? Agak-agak. Yes. How neural network works? Agak-agak lah. We don't talk a neural network lah. We talk about the perceptron first. Okay, so in a neural network, you need input, right? So it depends on how many. So this one you can treat as a features of the input. So you have the features here. We have one linear combiner, if you still remember, and then each input we assign the weight to this input. So we perform x1, w1, x2, w2, you get an x value here. To get an x value, so we need to compare the extra an activation function. So in this perceptron, we use step function together with one fraction value. So give you the one, right? So what is the purpose of predict y here?
Compare with the actual.
Very good. So you compare with the actual y to get what?
To get the weight.
Error, right? What is the purpose for error?
To get the weight. Get the weight.
To get the weight to get or
Adjust.
to adjust, very good. Send it back to here and to adjust this W1 and W2. And we repeat again until this weight is stable. So that is the overall idea. So if you combine these neurons together, so basically you will get like this one. You have a hidden layer. So you have a hidden layer. So let's say now we have only one hidden layer and 3 neurons. So this is how to be look like that. You have one. So you have a 2 hidden layers, and this is how it looks like. So we have a 2 hidden layers. Okay, so today we are going to see how to build the multi-layer neural network. Okay, how to build multi-layer neural network using these functions called neural net. Alright, if you don't understand these neural networks, then it will be probably very hard for you to understand the whole so-called practical. Okay, so we have two cases here. The first case is where I'm going to build a neural network, multi-layer neural network, which is only one hidden layer with 5 neurons. Okay, I'm going to build this one using one input. Okay, to generate one output using one hidden layer. With this one hidden layer consists of 5 neurons. Okay, for the first case, I'm going to use synthetic data, which is not the real data, but the fake data. Yeah, so we go through this one. So you install this, make sure that you install this neural net first. Okay, then you install this necessary library. You have a neural net NumPy PyLab. So for this second point here is where we create our own data set. We create our own data set using, we have an x, we have only one x here. Alright? So we would like to create the data set started from -7 and with 7. So in between, I need 100 data sets. So you have a -7, 7 and 100. It means that we have 100 data in between -7 to 7. Okay, so that is our x. So we would like to pump this x here into this equation, which is y equal to sine x multiply 0.1. Okay, so that I can create the actual one, the label. So I found this -7 here, you probably get some negative. I don't know what is the value. If you run this code, so this one I put the x here. So you will get this. So it means that we have a -7. We plug into this value, this equation, we get negative 0.328. So we have a second data, -6 point something. So we will get a value 0.272, and so on and so forth. We have about 100 data. So this is synthetic data, fake data. Okay, so we treat this is actual X, this is actual Y. Yeah. So now we would like to build a multi-layer neural network with one input, one output, and the hidden layer we have 5 neurons here. So how to build a neural network? So you have to identify first the range of your input. The range is -7, 7, so you have -7, 7, comma, followed by the number of neurons for the hidden layers. If you have 5 neurons here, then you put 5. You have 1 neuron, output neuron, which is 1, then you put 1. So this is your model. Okay? The first list here is the range for your input, first input, followed by number of neurons in the hidden layers, followed by the number of neurons in the hidden layers. If you have 2 input, x1 and x2, then you have to define x1, x2. Define the range. Then followed by the number of neurons. If you have 2 hidden neurons, 2 hidden layers like this, 3, 3, then you set 3, 3, and 1 output. So this is how we define. Okay, yeah? Yeah, the last practical, you will no chance to ask me question. Yeah, okay. So now here you can see that we use this function. So that is the function neural network feed forward things. So nl.net.new feed forward. So this is the syntax. So this is the range for your input, the neurons for the hidden layers, the neuron for the output layers. Okay, so we have this. Then we start to run this code. If we run this, then it means that we want to build this the model. Then we start to train the model. Okay, we have this model, we define this model first. Then we have a net.train means that we start to train using this neural network. We have to feed in the 5 input here. Input, your data set, your X. TAR is the output which I defined earlier. This is my output. TAR means that output. Okay. So the third parameters will be the epoch. Means that how many rounds you want to train the model. You will see whether in the lecture notes we have epoch number. Epoch 1 means that you train whole data set 1 time. You will put 500 means that you have to train for 500 times. Okay. Show is not an important parameter, just to show the value at every 2 epochs. You will put 1 means that every epoch you will show the errors. So what's the goal here? Goal is referred to the errors that we can tolerate. So do you still remember that we have the predicted type action? We get some errors here. So how much errors that you can tolerate? If you set 0.01, it means that if you calculate if the error is bigger than 0.01, you will start to feedback again and train until you reach this error. Okay, if you want the model to be very smart, then you set this value as low as possible. Okay, it means that you just allow very small errors in your model. But if you set very low, means that you take more time to run to train the model. Okay, so these are the 5 parameters we set. So when you start to run this code, then it will show you every epoch 2, the error is 28. It's quite big, so you will continue to learn, continue to train until you reach either you reach the number of epochs or either you reach your goal that you set inside your parameters at 0.01. So it reached already, it's lower than 0.01. It's stop. Okay? Here. Yeah. So if you want to find out after we train, let's say we train, finish. So after we train finish, right, then we will get the weight, right? We will actually adjust the weight, have the weight here. Alright. Okay. If you want to check the weight, the value of the weight, then you can write this code, which is not inside your Python file. It's an additional things. Because for me, it is not necessary to find out the weight. You are very busy. So this weight here is referred to you have a 5 weight, 1, 2, 3, 4, 5. You have a weight here. You have 5 weight, 1, 2, 3, 4, 5. And then you have a bias. Remember, we have a bias. So the models will adjust the bias as well. So you have a 5 bias. And then you have a weight hidden to output. So you have another weight here, right? Weight 6, 7, 8, 9, 10. You have another 5 weight from the hidden layer to output layer. That's why you have 5 weight here. 3, 4, 5. Okay? Alright, so the reason I showed this weight to you is I want to link back to the so-called the lecture note. So we have a weight. So how to find the weight? So this is the code. You can find it. But it's not necessarily to find the weight, just to show you the value here. Okay, so now, basically until this stage, you have already successfully built your artificial neural network model. Now, we would like to check whether your model is good or not. We have to test the models. So how to test the models? Who's in here? Okay, how to test the model? We built the model already, right?
Yeah, pretty easy. Okay, so continue.
Continue, huh?
Yeah.
Okay, come back to here. Okay, so now we build the model already. We finalize the weight already. Everything works already. Okay, good. So we can launch this for prediction. So how to do prediction? We will recycle this x value here. Okay, we will put -7 inside here. Okay, we will put -7, put here. We get some predicted 1. We will fit all the value inside this model, get all the predicted y. So we have an actual y. So we have a predicted y. We can compare. Okay, either you can compare using the mean square errors, mean absolute errors, or to have a better visualization, I plot a graph. Okay, y sin x here, so by right you will get some graph here. So this is based on the actual one. So I will plot another graph using the predicted values. So I will see whether it is overlapping or not. If overlapping means that your model is very good. You are able to predict all the x value accurately. If you get a value, a predicted value, something like this, then something wrong with your model. Okay, we have a predicted x, we have a predicted y, we have the actual y, then we can compare apple to apple. So check the models here. Yeah, we have an x here. Dot simulate is means that we start to do a prediction using the input. Okay, so this is the predicted output using the neural network model. So now we would like to compare apple to apple. Do you have this code? No, it's okay. Let me explain first. Later I'll show you the code that you copy that. Then the last code here is I compare overlap the actual graph, the actual data graph, compare with the predicted graph. If I code, and you will see that we have two graphs we have two actually data onto this one graph. The red line here is using the y sin the y equal to sine 0.5 multiplied x multiplied 0.5. So this red line is the actual data. So this cyan point here is the predicted output. You can see that overlapping, 100% overlapping. Which means that your predicted y is 100% equal to the actual y. Okay, what if let's say, now, I let you see, if I try to modify the neuron to only 2, instead of using 5 neurons, I reduce to only 2 neurons. Okay, instead of using 5 neurons, I use only 2 neurons. Let's see, I will retrain again. Okay, and then I will get the predicted output. So that is the predicted output. I will compare with the actual output. So this is the actual output. So this is the predicted output. So you can see that if I reduce the number of neurons, the model is become not sensitive. It's not accurate. The more neurons that I put, the more computational, the more calculations, the more sensitive, the more accurate is the model. But if you ask me how many neurons should I put, there's no fixed answer. We have to try it out. So now I want you to try to increase the number of neurons here. Maybe from 2, you increase to 3, see what the result. Increase to 4, increase to 5. It's not only that, you try to increase the number of hidden layers. Here, we have only one hidden layer, which is having a neuron 2. You try to increase number of hidden layers, and you compare again the result. Okay? So I will leave it to you first. Which part you want the code? Which part? This one, okay. This one.
Can we use your desktop to test?
We test lah. If you look at me, I test.
Use that desktop to test.
Test already. Now I want you to code and test yourself lah. Then only you can this one is it?
Yeah, can.
You have code for this one? Yes How about you? You don't have? Yes So I want you to adjust the neurons, the number of hidden layers, see what is the effect.
哪个没有的？这里没有。
加 PL 到
PL dot
Upper the graph.
expert
out equal to next dot C.
这个要改，这个是改去多少移动的，
OK 可以啊，继续。
然后这里要 set 这个。
But bear in mind, the more neurons that you put, the more time not to compute to run all the calculations.
你会直接来几？我放1万呢。
我放1万。5个人咩？
错错。
Yeah, there's only one input. It takes so much time. You put 1,000 neurons. What is that? Is the image that you learn today. Image that is actually consists of pixels, and each pixel you have 3 values. And how much information you need to train for the neural network?
直接在这。
大。
哦，
要等对ไหม哦 next sim test
这里。
再来。
这一孔。
后面这个是我的咩？还是这里？哦。哦，来，我们调。
You continue to run then correct the image.
如果这个是100，这样啊，这样等于1
那注定了。
哎，怎么了？这是什么东西？怎么我变洗毛灯了噻？
You can see that if you, although you add a lot of layers, but there's only one neuron now. The result is very
它是有 error 呢。
You see the result. Yes.
哦，它2是2条线的意思哈。它这个2代表是2条线的意思。2个 output 啊。哦。
More hidden layer, more neurons take more time.
哦。
You have 10 hidden, you can just calculate one value, very fast.
中间。
If you have this neuron, then you run.
这个调多少呢？这么夸张啊？稳啊！哎，太稳了，稳到没有东西耶。
那我有到一条直线。
没东西哦，这么稳啊！啊，上面的哈，太稳了，
稳的幸福。
稳摇啊，太稳了啊！
最稳就是稳跳。
Android 不是能暂停的咩？
可以啊，可以这样。
可以哦。
现在不是一个国家吗？
Alright, yes.
这就是马来
Shall we continue?
继续继续。
死了，没有的靠
有啊，那个
现在才按，
哪一个？
从休息过后开始讲。
嗯，你有事。
哎，no nothing。